Hello, welcome to today's lesson on section 12.2. This section is titled Arithmetic Sequences and Series. So I think the first order of business would be we got to talk about what is a sequence. A sequence is simply a set of consecutive integers or actually consecutive numbers. Let me rephrase that. Set of consecutive numbers that follow a certain pattern. So that's what's considered to be a sequence. A series is simply the sum of a certain number of terms in a sequence. So for example, if I had like 1, 4, 7, 10, 13, comma dot dot dot, that right there would be a sequence. But then if I had this, 1 plus 4 plus 7 plus 10 plus 13, that's a series because I'm adding up a certain number of terms in the sequence. Now what makes either of these arithmetic? That's if a common difference exists between consecutive terms. It looks like I forgot how to spell consecutive terms. So if you think about it, 1, 4, 7, 10, 13, hopefully you see the pattern. Every term differs, or consecutive terms differ by 3. So it seems like we're adding 3 every single time. So both of these here, 1, 4, 7, 10, 13, and 1, 4, 7, 10, 13, all added, are both arithmetic. But what if, you had a arithmetic series that lasted for 20 terms, or I wanted to find like the 40th term of the arithmetic sequence of 1, 4, 7, 10, 13. So that might be hard to count or list them all if you want to find some of the first 20 terms or the 40th term. So here's the question: are the formulas associated with arithmetic sequences and series? And the answer is a resounding yes. Here are the formulas. So the rule for an arithmetic sequence is the following. So A1 is always the first term. AN will be the nth term, meaning whatever term you're looking for. If you're looking for the 5th term, n would be 5, or the 6th term, n would be 6. N will be the number of the term. So again, if you're looking for the 6th term, you plug in 6 for n. And D will be the common difference. For a series, sum of an arithmetic series will just be this. Where Sm represents the sum of the first n terms. So if you're looking for the sum of the first 20 terms, n would be 20. So those are the formulas. Now let's do some examples. So for example 1, write a rule for the nth term of the arithmetic sequence below and then find A15. So clearly I want to use, let's try to find the highlighter. Clearly I want to use this formula here, right? So I do know the first term. And I do know the common difference. Hopefully you see it's 5. So an is going to equal 4 plus n minus 1 times 5. So that'll be your rule for the nth term, because we don't know what n is just yet. So an equals 4 plus n minus 1 times 5. And no need to distribute when just writing the rule. But now I want A15, so changing colors up. A15, that should be easy. 4 plus 15 minus 1 times 5. If you work it out, you should get 74, I believe. Yep, 74. So pretty simple. Let's try another one. One term of tick sequence is A19 equals 48. Common difference is D equals 3. Write a rule for the nth term. Okay. So AN equals this. Here's the formula. And by the way, I will give this formula to you on a test or quiz, so don't worry about having to memorize it. So anyway, we don't know A1. But if we let n equal 19, then A19 equals 48, and we can solve for A1. So if I let n equal 19, again, we know the common difference is 3. Remember, A19 is 48. So if you work it out, you should get 54. So A1 will equal negative 6. So your rule would be AN negative 6 plus n minus 1 times 3. So very, very simple. And then this one here. Two terms of arithmetic sequence are A8 equals 21, A27 equals 97. Find a rule for the nth term. So again, we have this formula. The problem is we don't know AN. Well, actually, we don't know A1. Nor do we know what D is. So a couple things you could do. You could try making two equations. So A8, A1 plus 8 minus 1 times D. We know A8 is 21, so 21 equals A1 plus 7D. Also, A27 equals A1 plus 27 minus 1 times D. A27 is 97, so 97 equals A1 plus 26 D. You can solve for D using a bit of algebra here. So do some substitution. Move things around, you get 76 equals 19D, so D equals 4. And if D equals 4, then A1 would be 21 minus 7 times 4. A1 will equal negative 7, I believe. Yep. So my rule, AN equals negative 7 plus n minus 1 times 4. Yep, that looks right to me. Another way you could have done it too, you could have said A27 minus A8 divided by 19 equals D. That's because there's 19 terms along the way from A8 to A27. That could have worked as well to find what D equals, because then you would have 97 minus 21 over 19, which would have been 76 over 19, which would got you 4. So you could do that way well and then find A1. Okay, lastly, what is the sum of the arithmetic series below? So we talked about sum notation on Monday during class, if you were here. But all it means is you plug in 1 for I, then 2 for I, then 3 for I, then 4 for I, and you kind of just keep going, dot, 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 until you plug in the last number, which is 20. But if you want to do this 20 times, that's kind of crazy. So if you think about it, you know it's arithmetic, and the first term is 8, second term is going to be 13, third term is going to be 18, so D equals 5. But even then, we just really need to use this formula right here. So S20 is going to equal A1 plus A20 divided by 2 times 20. A1 is easy, that's 8. A20, if you plug in 20, you should get 103. Divided by 2 times 20. And we should get, I believe, 1110. Yep, we get 1110. And that's it. So that covers 12-2. We'll do some practice in class during block 1. And we'll probably do some review of some other stuff as well. And we're all set. So I'll see you guys later.